Hello students, welcome to Vijetha IAS Academy and myself is Lenin Kaki and I am the Geography faculty of Vijetha IAS Academy. And in this video, we are going to discuss a small topic from geography, especially with respect to cosmology. Okay, in cosmology, there are different topics are there. How the universe has been formed, what are the different theories that are there in the universe, what are the different theories that are there with respect to formation of solar system, what are the different theories that are there, how earth is formed, how moon is formed, how the planets, asteroids, meteoroids, whatever that are there in the universe, everything, the star formation, everything will be discussed in this cosmology. But in this video we are going to discuss only a small subtopic of this one, that is how the universe has been formed. Is it clear? So there are a lot of theories are there which are going to explain with the formation of the universe, but in this video we are going to discuss about major three theories that are discussed about the formation of the universe. Okay, so those three theories are, okay, one is pulsating theory which is given by Arthur Eddington, and the second one is Big Bang theory which is given by Georges Lemaitre, and the third one is steady state theory which is given by Hoyles. Okay, so these are the major three theories that are there with respect to the origin of the universe. So we will see each and every theory in detail. Okay, so first one we will start with pulsating theory which is given by Arthur Eddington. Okay, so according to this pulsating theory, remember, according to this pulsating theory, the universe formation, okay, the universe has been formed in a cyclical manner. Okay, remember, so there is a continuous expansion will be there. After continuous expansion there will be once again contraction will be there. After this contraction once again expansion will be there, once again contraction. Like this a continuous cycle will occur or will take place. For example, if you see, let us assume this is the universe initial. After couple of years or millions of years, it will start expanding and it will start expanding further. Okay, after a limit once again there will be a contraction, there will be a contraction, there will be a contraction, like this in a cyclical way. So in one cycle it is expanding and in one cycle it is contracting. Is it clear? So this expansion is taking place because of some explosions. Okay, remember, this expansion is taking place because of some explosion, and this contraction is taking place because of gravity. This contraction is taking place because of, okay, this expansion is taking place because of some explosion, and this contraction is taking place because of gravity. Gravity will try to pull the objects towards it so that it will contract, its size will start reducing. Okay, so like this, in one phase it is going to expand and in one phase it is going to contract, and once again from here the size will increase, once again expansion will take place, and after expansion once again this contraction will take place. Okay, so like this expansion contraction will continuously will take place according to this pulsating theory which is given by Arthur Eddington. Okay, remember this one. From the picture also, if you see, after here some explosion has taken place, because of that explosion the expansion has been taking place. After this expansion once again the contraction has been taking place, and once this contraction is done once again some explosion will occur. So the same cycle will start continuously like this. So this is nothing but called as pulsating theory of origin of universe. Is it clear? Then next we will go to the second theory. Okay, from this picture also if you see, some explosion is taking place, expansion is taking place. Now once again because of gravity this is contracting. Is it clear? Okay, expansion and gravity contraction. Okay, so next theory, the second theory is called as Big Bang theory which is given by Lemaitre. Okay, so Big Bang theory, I think many of you know Big Bang theory, that around 13.7 billion years ago, remember what is the time period? 13.7 billion years ago. Okay, so all the mass that is present in the universe has been compacted to a single point, okay, which is very high density, high temperature, okay, high pressure system, which is having very high density, high temperature, high pressure system. Every mass, whatever the mass that is there in the universe has been compacted to a single point, has entire mass that is there in the universe has been compacted to a single point. Okay, so this single point is now having entire mass of the universe. Okay, so once everything is there in a single point, imagine the density will be infinite, the temperature will be infinite. Okay, so infinite temperature, infinite density will be there within that small compact point. That small compact point which is having infinite temperature and infinite pressure and infinite density is called as singularity. Remember this word singularity. The same singularity word will be there even when we discuss the black hole also, but remember, for time being, entire mass will be compacted into a single point which is called as singularity. Once entire thing is compacted in a singularity, okay, single point, the temperature is infinite. Once the temperature is infinite, everything will try to move away, right? So because of that one, gravity is trying to, high gravity means high density is there. Because of high density, high gravity is there. Gravity will try to pull objects towards it, but temperature is there. So that temperature will try to divert the particles that are there inside that one. So because of this contrast, a kind of explosion will take place. Because of this contrast, some explosion will take place which has occurred during this 13.7 billion years ago. A kind of explosion has been taken place from this singularity, which is nothing but called as Big Bang. Okay, this explosion is nothing but called as Big Bang. Okay, so once the Big Bang has taken place, let us assume this is the singularity, right? So at this singularity, temperature is infinite, density is infinite, everything is infinite. So because of that one, explosion has been taken place, and once the explosion has been taken place, the small particles started forming. Okay, so initially protons, electrons, neutrons are formed. Okay, so after explosion, after a couple of years, after millions of years, these particles started forming. Once these particles are formed, these particles came together. Okay, these electrons, proton, neutrons came together and they led to the formation of atoms. Okay, once different atom, okay, once different atoms, 2 or 3 different atoms came together and they formed into molecules. Okay, so different atoms came together and merged into formation of molecules. So these different molecules, whatever the molecules that are there, entire molecules are came together and formed into a gaseous cloud sort of thing. See, this is a kind of gaseous cloud. Inside this gaseous cloud, these molecules are there. Okay, this is called as gaseous nebula. Okay, this is called as gaseous nebula. From this gaseous nebula, okay, from this gaseous nebula, star has been formed. From this star, our planetary systems, our planets, everything has started forming. Okay, remember, so after explosion, protons, electrons, neutrons are formed. These are some particles are formed. From these particles, when they came together, they formed into atoms, and different atoms came together, formed into molecules. All these molecules are formed into a gaseous cloud, which is nothing but called as nebula. From this gaseous nebula, stars are formed. From these stars, different planetary systems have been formed, and one of the planetary system is our solar system, from where different planets of our Earth has been formed. This is the theory which was mentioned in this Big Bang theory. Is it clear? So singularity, which is having high density, high temperature, high pressure, everything almost will be infinite. Because of that one, it cannot retain into that single point. Because of that one, explosion has taken place, and once the explosion has been taken place, see, can you see in this explosion 4 particles are there. Okay, 4 particles are there. As it is expanding, means with time explosion will be expanding, right, because of explosion. So these 4 particles have been distributed like this, the same 4 particles, because everything is expanding here. So because of this one, okay, because of this one, expansion has been continuously taking place. So because of this one, okay, this expansion has been even continued today. Okay, in 1929, see, we have to know we have to know whether the universe is expanding or not. We have to have some proofs, right? So in 1929, one person called as Hubble, okay, using his telescope, Hubble used his telescope called as Hubble's telescope, and he observed that the universe, whatever the particles or whatever the stars, whatever the systems that are there in the universe, galaxies, all these things are there, right? All these things are expanding or moving away from each other, okay? So what this Hubble has discovered that whatever the planetary systems, not planetary system, we have to say it is galaxies, whatever the galaxies or whatever the star systems that are there in the universe, the distance between the star systems has been increasing. This is indirectly indicating that when the distance is increasing means it is expanding. So previously if you see it is hardly, let us assume 10 centimeters. Here it is 15 centimeters, but now if you see here 20 centimeters, okay? So like this, the distance between the stars has been increasing. This is what they have observed by the Hubble through his telescope in 1929, and which is saying that the Earth or the universe has been expanding, which is nothing but which was mentioned through this Big Bang theory. According to the Big Bang theory, the universe is still expanding, which was substantiated by this Hubble in 1929 through his telescope, and he has mentioned that the universe is moving through red shift. It is moving towards red shift. Remember this word red shift, but we will discuss what is red shift and blue shift in coming videos. But time being, remember the Earth or the universe has been moving towards this red shift, that is nothing but expanding universe. Is it clear? This is the second theory which was mentioned with respect to origin of the universe, and the last theory is nothing but called as, see, can you see here, expanding universe, this one, and the last theory is steady state theory. Okay, remember the last theory is called as steady state theory, and in this steady state theory they are saying that, see, everything is constant, the size and mass of universe is constant. So remember, the size and mass of universe is constant. Okay, so according to this theory, the size and mass of the universe is constant. Okay, remember this one in this steady state theory, but it has mentioned one more word, that there is an observable boundary. Okay, so let us assume there is some boundary. Okay, this is the boundary. Let us assume this is the boundary, and let us assume this is the universe that is present in the center. Okay, this is the universe that is present in the center. So what this theory is saying is, whatever that is there within this boundary, which is called as observable boundary, whatever that is there within this observable boundary, then that thing is called as our universe. Okay, but we have seen, according to the past theories, universe is always expanding. So this universe will start expanding, right? This universe will start expanding. Okay, so with expansion, its size will keep on increasing. Its size will keep on increasing. Its size will keep on increasing like this, right? So this is the observable boundary, and at one point of time, the size of the universe has been increased beyond this observable boundary. Okay, remember, the size of universe has been expanded beyond this observable boundary, but what I have just mentioned, whatever that is there within this boundary is treated as universe. Okay, whatever that is there within this observable boundary is treated as our universe, and whatever that has crossed beyond this observable boundary, this is there, right? This is there. Whatever that has been crossed beyond this observable boundary, that we cannot see, and that is not treated as our universe. Okay, whatever that has been crossed beyond this observable boundary, that is not treated as our universe, and whatever that is present within this observable boundary, it is treated as our universe. Now let us see here. See, whatever the particles that are there, okay, these particles, when they started moving into this one, those particles are not observed and they are not considered as part of our universe, but in that process, a new particles will be generated from here. Okay, in that process, a new particles will be generated here, and some particles will be going away. So these particles which are going away are not considered as part of universe, but a new particles are generated, so that every time new particles are generating at the center, and at the boundary some particles are going away. So there is a balance between formation of new particles and some particles which are going away. So because of this balance, at any point of time, if you see, the mass and size of universe is constant, because this is the size of universe, right? This red dotted line is nothing but the size of universe, and it is constant because whatever that is there within that red dotted line is considered as our universe. So the size of universe is constant, and also as some particles are going away, some mass has been reduced, but at the same time the same amount of mass of the particles will be generated in the center of the universe, which is maintaining the mass constant. Okay, so with this we can say the size of the size of the universe is constant, and also the mass of the universe is constant, because whatever the mass that is going away from this observable boundary, the same amount of mass is generated. So the balance will be reached, so that mass of the universe and size of the universe is always constant. That is what that is mentioned in this steady state theory. Okay, is it clear? So these are the major three theories that are talking about the formation of universe or origin of the universe. There are other theories also, but these are one of the most acceptable theories, and out of these theories, Big Bang theory is the most acceptable out of all the theories. Okay, thank you students.